The James Webb Space Telescope has just sent Earth a massive warning, and it's getting closer. This warning comes from the exoplanet Proxima B. With each new image sent back, more questions arise, leaving authorities terrified. Each snapshot from this distant planet makes us wonder more about the mysteries of the universe. Growing questions are arising about a potential enemy planet near Earth. Could there be a neighboring alien planet that has hostile intentions? Could Proxima B pose a threat to our very existence? The question of alien life has intrigued humanity for centuries, but with modern technology like the James Webb Space Telescope, it has become a question we can explore more thoroughly than ever before. Yet the universe isn't making it easy to find answers. We continue to use our best tools, such as the James Webb Telescope, to capture glimpses of distant planets and galaxies, hoping to find clues that might hint at life beyond Earth. Let's be realistic, though. Every new image and piece of data mostly serves to remind us of how little we actually know. While these discoveries could be groundbreaking, they also highlight the vastness and complexity of the cosmos, leaving us with more questions than answers. Understanding a far-off planet like Proxima B could redefine our place in the universe. For scientists in astrophysics, this is thrilling, but for the general public, it often feels like just another piece of space news, distant, abstract, and sometimes overwhelming. These revelations raise more questions than they answer, leading many to wonder what this means for life on Earth. Could Proxima B really harbor life or even intelligent life that might one day pose a threat to us? Despite the immense power of the James Webb Space Telescope, it can only show us so much. Sure, we've learned some incredible things, like the fact that we now have stunning new images of Proxima B, and we know that the universe is even bigger than we ever imagined. But what comes next? The practical implications of these discoveries can feel as vast as the universe itself. Proxima B, discovered in 2013 due to its gravitational interaction with its star, was a major scientific breakthrough for many scientists. Finding this exoplanet was like discovering a new cosmic neighbor. Proxima B is just slightly larger than Earth, and it orbits its star every 11 days, making it an intriguing subject for further exploration. From a scientific perspective, the idea of another world so close to ours is exhilarating. Yet for most people, it's hard to connect with a place that's 25 light-years away. To put that into perspective, even the fastest spacecraft humans have ever created would take tens of thousands of years to reach it. Imagine what it would be like to stand on Proxima B. Its star, Proxima Centauri, would appear as a big dim red light in the sky, much cooler and darker than our sun. Proxima B orbits so quickly that a year there lasts just over a week. One side of the planet always faces the star, meaning it is locked in perpetual daylight, while the other side is shrouded in endless night. It sounds like something out of a science fiction novel, but the reality would be far more brutal. On the bright side of Proxima B, any water would likely boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a calm and steady neighbor like our sun. It throws out dangerous flares and intense radiation, making the surface of Proxima be a hazardous place for life as we know it. This isn't exactly the kind of neighborhood where humans would want to set up camp. Interest in finding life beyond Earth hit a peak in late 2020 when scientists detected an unusual signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had a unique frequency of 982.551 MHz, which caught everyone's attention. Such a signal could, in theory, be an indication of advanced technology, though it is far too soon to draw any conclusions. More recently, the James Webb Space Telescope fueled even more excitement by suggesting that Proxima B might have water vapor in its atmosphere. Water, as we know, is a fundamental ingredient for life, and its presence could be a game changer. To better understand how much water is present on Proxima B, scientists are employing advanced techniques like spectroscopy. This method allows them to detect the gases that surround the planet, acting like a high-tech detective tool. By analyzing the planet's light spectrum, scientists can identify specific gases such as oxygen, methane, and carbon dioxide, all of which are essential for life. Atmospheric modeling is another key approach. By using computer simulations of Proxima B's atmosphere, scientists can make educated guesses about its conditions. These models serve a similar purpose to how paleontologists use dinosaur bones to reconstruct what dinosaurs might have looked like. However, the more we learn about Proxima B's atmosphere, the more we are reminded of the incredible diversity of life forms that exist here on Earth. Extremophiles, for instance, are tiny organisms that can survive in extreme conditions: boiling hot springs, acidic lakes, and the freezing cold of Antarctica. These resilient creatures demonstrate that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be equally adaptable? The pursuit of life on Proxima B presents enormous challenges, not just in terms of space travel, but in proving that life can exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere might not offer much protection. Additionally, the distances involved are so immense that new types of propulsion systems are necessary to make space travel to Proxima B feasible. Concepts like solar sails, ion propulsion, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their infancy and require extensive research before they can be used in real missions. While dreaming about future space travel is thrilling, we need to remain realistic. Discovering life on Proxima B is fraught with technological and scientific challenges. Only by advancing our technology and deepening our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This pursuit is not merely about satisfying curiosity. It's about pushing the boundaries of human achievement. Could we one day set foot on Proxima B or even make contact with life there? As we consider the long journey to Proxima Centauri, the idea of finding aliens no longer feels confined to the realm of science fiction, but instead seems like a real, tangible possibility. This exciting shift from a distant dream to a scientific endeavor has attracted serious attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating immense resources to transforming what would typically be an impossibly long journey, one that could take tens of thousands of years using today's technology, into a mission achievable within a few decades. The goal of reaching another star system within a human lifetime has sparked innovation and optimism in the scientific community. However, these grand ambitions are quickly tempered by the stark realities of our current technological limitations. Despite remarkable advancements in space exploration, the idea of traveling to Proxima Centauri, even at 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey feasible in any reasonable time frame. Breakthrough Starshot, one of the most notable projects, envisions using powerful laser-driven sails to propel tiny spacecraft to speeds up to 20% the speed of light. While this concept shows promise, it's still in the experimental stage and requires overcoming numerous technological and logistical hurdles, such as minimizing damage from space debris and ensuring accurate long-distance communication. While the dream of reaching Proxima Centauri and potentially discovering alien life is closer to reality than ever before, it remains grounded by the constraints of present-day technology. Accelerating a spacecraft to near the speed of light with today's tools feels almost impossible, like trying to solve a difficult puzzle in the dark. Even bold projects like Starshot, which aims to propel a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere creates disturbances for the lasers, making it difficult for space exploration tools to function with the precision required. One suggested solution is the use of adaptive optics, smaller lasers on satellites that continuously monitor and adjust for atmospheric disturbances. This system would help powerful ground-based lasers remain focused on spacecraft as they travel through space. However, the laser propulsion technique demands an enormous amount of energy, equivalent to the total energy consumed by the entire United States, and it would only work for a short period. Imagine setting up 100 million lasers over a vast area just to push a small spacecraft only 33 feet wide to 20% of the speed of light. At this speed, the spacecraft would still take 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. But the challenge of reaching Alpha Centauri isn't solely about overcoming technical obstacles. There are natural barriers as well. The gravity of the sun, the presence of space debris, and the sheer vastness of the distance involved all pose significant risks. Even communicating with a spacecraft en route to Proxima B would feel like sending messages through time. It would take about 4 years for a signal to reach it from Earth. Despite these daunting challenges, the desire to explore other star systems continues to grow. It's driven by humanity's deep-rooted love for discovery and exploration rather than practical necessity. Even bold projects like Starshot, which aims to shoot a spacecraft toward Alpha Centauri using lasers, face many practical challenges. However, solving these problems could revolutionize space exploration. Still, the potential risks involved, including communication delays and natural hazards, require thorough planning. Despite the difficulties, many scientists believe that the rewards far outweigh the risks. The idea of discovering life on Proxima B or another distant exoplanet continues to captivate imaginations worldwide. Discovering life on another planet would be the most groundbreaking scientific discovery in human history. It would not only reshape how we see ourselves and our place in the universe, but could also provide insights into the origins and future of life on Earth. While humanity dreams of a future where we can travel to the stars, we are also taking practical steps in our search for life. The discovery of planets like Proxima B is just the beginning. Telescopes like Kepler have been pivotal in identifying distant worlds that could potentially support life by observing how these planets interact with their stars. Either by blocking some of the starlight as they pass in front or by making the stars wobble due to gravitational pull. We can learn more about their size, composition, and potential habitability. Now that Kepler's mission is complete, the James Webb Space Telescope is stepping up to take over. Its ability to detect infrared light allows it to study planets that were previously too dim or distant for us to analyze. As we learn more about Proxima B and other exoplanets, we are expanding our understanding of the universe, and with it, the possibility of life beyond Earth. The James Webb Space Telescope has opened new doors in the search for extraterrestrial life, particularly with the discovery of exoplanets like Proxima B. While we are still in the early stages of exploring the potential for life on this distant world, the technology and curiosity that drive us will continue to push the boundaries of what we know. Whether or not Proxima B harbors life, the quest to understand it has already reshaped how we think about the universe and ourselves. As we delve deeper into the mysteries of the universe, the search for extraterrestrial life takes on new urgency and excitement. The advancements in technology, particularly in observational astronomy, have enabled us to peer farther into the cosmos than ever before. Instruments like the James Webb Space Telescope are revolutionizing our understanding of planetary systems, allowing us to analyze the atmospheres of distant worlds and uncover potential signs of life. One of the most intriguing aspects of Proxima B is its location in the habitable zone of its star, where conditions might allow for liquid water to exist. This region is often referred to as the Goldilocks zone, where temperatures are neither too hot nor too cold, creating an environment conducive to life as we understand it. Scientists believe that if Proxima B has the right atmospheric conditions, it could potentially sustain life forms, even if they differ significantly from those on Earth. Moreover, the study of Proxima B opens a window into the conditions that may have shaped life on our own planet. By examining the geological and atmospheric characteristics of Proxima B, researchers can gain insights into planetary formation and evolution across different star systems. Such comparative studies could illuminate the processes that lead to habitability, offering clues about how life might arise in diverse environments. Astrobiology, the field dedicated to the study of life in the universe, plays a crucial role in this exploration. Researchers in this discipline are not only focused on finding life, but also on understanding the potential for life to adapt to extreme conditions. This knowledge could enhance our search for life in places previously deemed inhospitable, such as icy moons like Europa or the methane lakes of Titan. The excitement surrounding Proxima B is not just about the possibility of discovering life. It also underscores humanity's innate desire to explore and understand our place in the cosmos. As we ponder the potential existence of intelligent life forms, ethical considerations come into play. If we were to encounter extraterrestrial civilizations, how would we communicate? What protocols would we establish to ensure mutual respect and understanding? In addition, the societal implications of discovering life elsewhere are profound. Such a revelation could challenge existing beliefs and philosophies, prompting a reevaluation of humanity's role in the universe. It could inspire a new era of collaboration, as nations and organizations unite in a common quest for knowledge and exploration.